Hello there, Mr. Chan, doing Algebra 1, Topic 2, Section 2-1 called Slope-Intercept Form. Please turn to page 31 of your note-takers, Student Companion, and let's get going. We have an opener here that we're going to go ahead and skip. We'll probably work on some graphing calculator work in class. So let's not worry about this at all. All right, here we go. We are going to go ahead and get started with the actual examples on the next page on 32. Let's go ahead and move there. All right. Well, this whole chapter is about graphing lines. And in this case, we're going to do something called slope-intercept form. That makes a connection between x's and y's in the equation. The equation is y equals mx plus b. The variables that we are referring to are x's and y's. The other two variables are values that help graph it. The coefficient, or the number in front of x, is called the slope of a line. Slope of a line is referring to how steep or how shallow a line is drawn from left to right. You might hear teachers talk about the rise over run. It's a ratio. How far up versus how far over it goes from one point to the next on this line. Rise is in the y direction. And run is in the x direction. The other value in this equation, y equals mx plus b, is the number by itself, or the constant b. This is called the y-intercept. It literally means where the line crosses the y-axis. All right, let's do some examples. I'm going to go ahead and do the one from the book off to the left first. Here it is. Graph, or sketch, y equals 4/5, that's a fraction, x plus 2. If you compare it to the slope-intercept form, y equals mx plus b, you can extract a lot of information from there. Okay. It's already in slope-intercept form. 4/5 is the slope of the line. And before we can apply the slope, we have to start somewhere. And that somewhere is called the y-intercept, b. Let me show you. Go ahead and graph coordinate plane down here. It's made of two axes. The x-axis is horizontal from left to right. Where they intersect, of course, is the origin. We call that 0, 0, the origin. Anything to the right of the x-axis, of course, is positive. Anything to the left of the x-axis is negative. The y-axis, anything going up is positive. Anything going below the origin is negative. Let's go ahead and put some marks here. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So we're kind of focusing on this upper right-hand quadrant, it's called, separated by these axes. This is quadrant 1 in the upper right-hand part of this coordinate plane. And in this case, we got to start somewhere. You always want to start with the y-intercept in this slope-intercept form. The y-intercept is positive 2. At 2 on the y-axis, put a dot there. This is where you are at. That's where you start. Think about that for a second. That point right there, the x value is technically 0. This is the y-intercept. In the equation itself, you plug in 0 into that equation. 0 times 4/5 is 0, leaving you with a 2. That's where we get the 0, 2. From there, we got to go somewhere. And to go somewhere, we apply the slope of the line, and that will help us graph it from left to right. The slope of the line is positive 4, that's the y direction, and positive 5 in the x direction. So 4/5 is the slope. Ready? From the y-intercept, 1, 2, 3, 4, that's positive 4 for the rise, and then positive 5 for the run. 1, 2, 3, 4, 5, right there. And all you have to do is connect those two dots, and you're done. This is considered to have a positive slope. It's rising from left to right, and you're done. That's your graph. Using that knowledge, let's try to apply that to the example in your note taker, negative 3/4 x minus 5. Now you have kind of a decision here. Negative 3/4 can be seen both ways in terms of the slope itself. Negative 3/4 can be interpreted as negative 3 over positive 4 or positive 3 over negative 4. We'll keep that in mind and see which one is correct, or maybe both of them are correct. We'll see in a second. Negative 5 is where you start. This is the y-intercept. Okay. Let's draw some axes this way. Split the coordinate plane in half. And let's focus on the bottom two quadrants, because my y-intercept is negative 5. I'm going to be below the x-axis. So when you're drawing axes, sometimes you have to kind of eyeball it. Negative 5, I got to start there. Negative 1, negative 2, and so on. And there's my negative 5. This is where you are. This is where you start. Now, the second thing I have to do is find a point through which this line crosses. And I have to apply the slope. The slope is either negative 3/4 or 3 over negative 4. Let's see what happens when we try to do both of them. Here we go. From negative 5 on the y-axis, negative 3 over 4 goes to right there on that point. Okay, that's negative 3, positive 4. If we went the other direction, did positive 3, up 3, negative 4 goes to the left, those two blue dots that I just placed down, depending on how you interpret the slope, actually fall on the same line. Apply the negative sign to one of the numbers, but not both, and you'll be on the same line. There it is. This particular graph has a negative slope. And I forgot to mention about uphill and downhill. Think of this as going downhill from left to right. The other one's going uphill. Might as well put that up too. There. All right. What do you guys think? Have you done this before? Moving on to example 2. All right. This time, we're going to work backwards and come up with the equation that is represented in this graph. We're going to write the equation in slope-intercept form, y equals mx plus b. All we have to do is figure out what the heck the y-intercept is, and then figure out what the heck the slope is, based off of the picture. All right, we have this line that's crossing the x and the y-axis. The one information that I jumped to right away is the y-intercept right there. Reading that coordinate point is not easy for all students, so be careful here. Someone can accidentally say 2 or -2, 0, so be very careful. We need the coordinate point of that. And the x value is 0 because I'm not going left or right, but I'm going down in the y direction. That's -2. That's your y-intercept is -2. Okay, that's where it crosses the y-axis right there. -2, bam. Just put that in. Equals mx plus -2, or I don't care, -2. It's the same thing. Halfway done. All we have left now is finding the slope. Slope in this case is rise over run. This particular line is going uphill, which tells me my answer has to be positive. Okay, here we go. Usually the slope is a fraction. All right, so eyeball the graph, and you see that there are a couple of points that they've highlighted for us already. We have this point on the y-axis, and this point right here is a great place to end up. How do I get to that second point from the point on the y-axis? Well, in the y direction, I have to go up. So I have to go up 2 jumps there. There's my +2. That's my rise. Then from there, I have to go to the right, 1, 2, 3. That's my run. Ladies and gentlemen, there it is. +2 over +3. That's your final answer. Let's throw in another example for practice. This is the one I believe is in the book. It consists of a line that has a couple of major points on there, and those points are at 0, -1, and -1, 4. So let's put those in. 0, -1, and -1, 4. I believe this is in the book. All right, let's set this up. Y equals mx plus b. Let's find our 2 pieces of information. First off, let's jump to the y-intercept first. Hey, where does it cross the y-axis? Ah, -1. Great, let's put that in. Second question, what is the slope from that point? We're going to go from that point on the y-axis to the other point that's been highlighted at -1, 4. All right, remember, slope is rise over run now. Let's look at the rise here. I need to go up. 1, 2, 3, 4, 5. So there's that. Then from this point right here, where my blue jump ended up, I have to go left. Left on horizontally is a -1, like that. That's it. I'm done. +5 over -1 is -5x. You can just shrink that together, and that will give you your final answer. -5x minus 1. You can leave it over 1 if you want to. It's not a big deal. All right. Not all the time do they give you that information quickly when you're trying to uncover mx plus b. Let's go to the next page, page 33. Let's try to understand slope-intercept form, but this time instead of a graph or information that you can just plug into y equals mx plus b, let's jot that down. Sometimes they don't give you the y-intercept. You have to figure that out yourself. Now, I'm about to help you out here. The third example asks, write the equation in slope-intercept form of the line that passes through the points 5, 4 and -1, 6. Slope has its own formula. Here it is, folks. M equals y2 minus y1, those are called subscripts, divided by x2 minus x1. Technically, it's still rise over run. Rise are the y values, run are the x values. Those subscripts 1 and 2 are referring to the point value. 5, 4 in example 3 could refer to my first point of the line through which it crosses, and -1, 6 could be referring to the second point it crosses. Now visualize that, 5, 4 and -1, 6. I mean, I can try to figure it out. 5, 4, -1, 6. 5, 4 is about right here, maybe. And -1, 6 is about right here. The problem is we don't know where it crosses the y-axis. That y-intercept there could be a whole number, but I kind of doubt it, whatever the heck this line is. So we have to use a secondary formula to figure out what the heck the y-intercept is, okay? All right, let's do it. We don't know the y-intercept. We can find this slope by plugging in those two corner points into the slope formula. So let's do that first. Let me get this ready. Plus b. B we'll get in a moment, but we got to figure out what the heck m is. M is first. All right. Y2 is referring to the y value of the second point. If it helps, label those corner points with subscripts so you know what values to plug in. Oh, Y2 is 6, put that there. And those minus signs are part of the formula, not part of the number, so please be careful there. Y1 is next, that's 4. Great. Going on, moving on to the denominator, x2 is -1. x1 is 5. And now we just have to clean this up. 6 minus 4 in the numerator is 2. -1 minus 5 in the denominator is -6. Ouch. That fraction can be reduced by 2 in the numerator and the denominator, and you will get 1 over -3. Already this is looking kind of scary. Let's put that into there. -1/3 is the slope we just found. And be careful, it doesn't really matter. That negative sign could be attached to the 1 or the 3, but not both. B is the last variable we have to solve for next. This is the y-intercept. Now, to do this, we're going to use some substitution into x and y, the other part of the equation. X and y is a point that makes this equation true. Actually, we have two choices here. We are given a couple of points through which this equation is true. You actually have a choice. You can pick x1, y1 or x2, y2 to plug into x, comma, y. It doesn't really matter. Let's go and plug in 5, 4. Substitute 5, 4 into this equation. 5, 4, 5. Oh no, we're going to get a fraction. A really ugly fraction. Wow. So let's clean this up. 4 equals -1/3 times 5 is -5/3 plus b. Fractions happen in this course. Let's isolate b by moving the -5/3 to the other side. Let's go ahead and add 5/3 to both sides. All right, b equals to, wow, this is scary. 4 over 1 plus 5/3. Let's change let's change those fractions into a common denominator, which is 3 multiplied by 3. That'll give me 12 over 3. Sound right, everybody? So 12 plus 5 over 3, the common denominator, that gives me 18/3. Is that 17/3? Whoops. That would have been too easy, right? So that's 17/3. Leave it as an improper fraction, please. Don't convert it to a mixed number. That would be very confusing. Leave it as an improper fraction reduced. Do not convert it to a mixed number. That's going to be confusing in algebra. No mixed numbers, everybody. Done. Final answer. Y equals, those x's and y's reset to a generic general equation for this graph equals to negative 1/3 x plus 17/3. And that is your final equation. All right, that was definitely very challenging. We're going to skip example 4 and jump to the last page. Here we go. Woo. All right, number 5 and 6 involve some graphing. I'll go ahead and put the equation y equals mx plus b off to the side. And also my slope formula. The difference of y's over the difference in x's. Oops. When I say differences, I mean, you know, subtraction. Rise over run. Slope. Y-intercept. Rise over run. All right, let's create some axes here for number 5. I think we barely got that in. That negative 5 is kind of screaming out at me. Negative 5 is the y-intercept. Let's go to the y-axis, go to negative 5. Put a dot there. There's your starting point. We got to go somewhere. That's the slope, the coefficient in front of x. 2 can be rewritten as a fraction when you put it on above 1. There's my rise over run. Up 2 over 1. Up 2 over 1. Up 2 over 1. Up 2 over 1. And there it is, ladies and gentlemen. There's my graph. From negative 5 on the y-axis, up 2 over 1. All right, like a staircase. Number 6. Let's go ahead and break out those axes too. Great. My y-intercept is positive 2. Great. Go to 2 on the y-axis, put a dot there. From there, I'm going to apply a slope. And I have a negative. And you can apply it to either the 3 or the 4, but not both. It doesn't really matter. I'm going to call it negative 3 over positive 4. Okay. Negative 3 is the y direction. Go down 3. 1, 2, 3, and over 4 to the right. 1, 2, 3, 4. Okay, bam. Connect those two dots, and you're done. Easy as that. Notice that this one's going downhill. The slope is negative. They're synonymous with each other. The other one was uphill. Forgot to mention that. Great. Let's go ahead and do number 7 and 8. Oh, these are not that bad. Identify the slope and the y-intercept for the line of each equation. Easy enough. The slope is the number in front of x. It's in slope-intercept form. So there it is. That's the slope. Negative 5 over 1. The y-intercept is the number by itself, or b. That is negative 3/4. Pretty easy. Same thing with number 8. Slope is the number in front of x. 1/4 in this case, and the y-intercept is +5. Wow, not too bad. All right. Number 9. And 10 involves coming up with equations. Let's identify some major points here that kind of pop out. I see the y-intercept, of course, for both of them. That one right there looks like +1. The one over here looks like -2. And let's go ahead and find a point through which it crosses nicely on the grid. There's a nice point right there. And there's a nice point right there. That will help us with our slope. Number 9, y equals mx plus b. And same thing with number 10. Sometimes I write boxes to represent what we're trying to figure out. All right. So for number 9, the y-intercept is 1. Great. And number 10, the y-intercept is -2. Put that in. That was easy. Slope for number 9 is downhill. That means my slope is going to be negative. In this case, it's going to be down 2 over 1. That's my slope. Down 2 over 1, -2 over 1. Okay. And for my other one, looks like I have to go up to the same level as the second red dot, up 3 over 2. And there's my slope for that. And guess what? That's it. That wasn't that bad. Any questions? Number 11 and number 12 is exactly like example 3 that we did on the previous page. I will crank through that right now. There's not a lot of space here, so I'm going to use some space off the way left there. Before I do that, let's go ahead and label those corner points, x1, y1, x2, y2, and the same goes for the bottom one too. They're essentially the same problem, different numbers. It's good practice though. First things first, find the slope for both of them. Remember the slope formula looked like this. Okay, so let's put the numbers in. For the first one, let's plug it in. y2 minus y1, x2 minus x1, and clean that up. Ooh, that's not going to be pretty. My slope for the first one is 4/3. It's half the battle. I got to find my y-intercept second. I'll come back to that in a second. Why not? All right, let's do the same thing with number 12. I'm kind of like doing this in an orderly fashion. 2 problems at once. 4 minus -5, and then 2 minus -1. Just keep track of your negative signs. 4 minus -5 is 4 plus 5. 2 minus -1 is 2 plus 1. Ooh, this is much nicer, +3. Great. To find the y-intercept, I need to use the slope-intercept form. Let's do that for number 11 first. Here we go. Y equals the slope we just got, 4/3 x plus b, the second variable we're trying to figure out. To do that, I need to plug in something for x and y. We have 2 choices. One of the choices stands out very, very, very easily, and that makes my life so much easier. I don't have to deal with fractions. 0, -3 would be a great point to plug in to my equation to solve for b. Let's plug in 0 for x and -3 for y. 0 times anything is 0. That's why I chose it. So that 0 is out right there. Boom, b equals -3. And I'm done. It's that simple. Rewrite the equation, resetting the x's and y's. Y equals 4/3, x minus 3. The answer we just got on the other side right there. And there's your answer. Yay. All right. I'm going to do the same thing with number 12. There we go. Y equals 3x, the 3 we just got for the slope, plus b. Pick a point. It doesn't really matter which one you pick. I'll pick 2, 4. No big deal. You could pick -1, -5, and you'll get the same answer. Trust me. Let's plug in 2, 4 into the equation and see what happens. 4 equals 6 plus b. Subtract 6 to both sides. b equals -2. Sweet. We're done. Final answer, y equals 3x minus 2. And that, ladies and gentlemen, concludes 2-1 slope-intercept form for Algebra 1. I hope you understood some of that. If you have any questions, please ask. I'm always there to help you guys out. Good luck. Have a nice day.